X-intercepts and Y-intercepts of rational functions. The x-intercepts of a rational function are the values of x when f of x is equal to 0, which will not make the denominator 0. Suppose we have a rational function f of x is equal to numerator over denominator. From the definition, the x-intercepts are the values of x when f of x is equal to 0. Meaning, to solve for the x-intercepts, we must replace f of x with 0, then solve for x. We can simplify this equation by cross multiplication. 0 can also be written as 0 over 1. 1 times numerator is numerator equals denominator times 0 is 0. The first step to solve for the x-intercept of a rational function is to set the numerator equal to 0, then solve for x. Take note that the x values that we can solve from this equation are just candidates for x-intercepts. So we need to check if the x value is an x-intercept or not. Second step, substitute each of the x values for x in the denominator. If the x value gives you a non-zero number, then it is an x-intercept. On the other hand, if the x value gives you 0, then it is not an x-intercept, but either a whole or a vertical asymptote. A rational function may have many x-intercepts or no x-intercept. The y-intercept of a rational function is the value of f of x when x is equal to 0. Y-intercept can be represented by f of 0. In evaluating the function at x is equal to 0, three possible answers can be obtained: a real number, an undefined result, or indeterminate form 0 over 0. If you obtain the last two, it means that the rational function has no y-intercept. A rational function can only have one y-intercept or nothing. Remember that if one of the x-intercepts of a rational function is 0, 0, then its y-intercept is also 0, 0. Example 1. To solve for the x-intercept, the first thing to do is to equate the numerator to 0, then solve for x. X plus 6 is equal to 0. Transpose positive 6, we have x is equal to negative 6. At this point, we are not yet sure if negative 6 is the x-intercept of the rational function. So we need to substitute x is equal to negative 6 into the denominator. When x is equal to negative 6, 2 times negative 6 minus 3 is equal to negative 12 minus 3, which gives us negative 15. Since negative 15 is a non-zero number, we can say that x is equal to negative 6 is the x-intercept of the function. So the x-intercept of the function is negative 6, 0. To solve for the y-intercept, just plug in 0 for x, then simplify. F of 0 is equal to 0 plus 6 all over 2 times 0 minus 3, which is equal to 6 over negative 3, which can be simplified to negative 2. The y-intercept is 0, negative 2. Example 2. The numerator is 4x minus 12. 4x minus 12 is equal to 0. Transpose negative 12, we have 4x is equal to 12. Divide both sides by 4, we have x is equal to 3. Let's substitute 3 for x in the denominator to see if it is an x-intercept or not. When x is equal to 3, we have 9 minus 3 times 3 is equal to 9 minus 9, which is equivalent to 0. Since the result is 0, we can say that 3 is not the x-intercept of the function. So the function has no x-intercept. For the y-intercept, we have f of 0 is equal to 4 times 0 minus 12 all over 9 minus 3 times 0, which is equal to negative 12 over 9, which can be simplified to negative 4 thirds. The y-intercept is 0, negative 4 thirds. Example 3. For the x-intercept, we have 5x. 5x is equal to 0. Divide both sides by 5, we have x is equal to 0. Substitute 0 for x in the denominator. When x is equal to 0, 7 minus 10 times 0 is equal to 7 minus 0, which is equivalent to 7. Since 7 is a non-zero number, we can say that 0 is the x-intercept of the function. So the x-intercept is 0, 0 or origin. For the y-intercept, since the x-intercept is 0, 0, even without solving, we know that y-intercept is also 0, 0 or origin. Example 4. For the x-intercept, since the numerator has no variable, we can say that the rational function has no x-intercept. For the y-intercept, we have f of 0 is equal to negative 27 all over 0 squared plus 3 times 0 minus 9, which is equal to negative 27 over negative 9, which can be simplified to 3. So the y-intercept is 0, 3. Example 5. The numerator is x squared plus 2x minus 15. So we have x squared plus 2x minus 15 is equal to 0. Since we have a quadratic equation, the first thing to do is to try to factor out the expression. The quadratic can be factored into x plus 5 times x minus 3. To solve for the possible x-intercepts, we need to equate each factor to 0, then solve for x. First, we have x plus 5. X plus 5 is equal to 0. Transpose positive 5, we get x is equal to negative 5. Next, we have x minus 3. X minus 3 is equal to 0. Transpose negative 3, we get x is equal to 3. Next, we need to substitute each value of x for x in the denominator to test if the x value is an x-intercept or not. When x is equal to negative 5, we have negative 5 squared minus 12 times negative 5 plus 20, which is equal to 25 plus 60 plus 20, which gives 105. Since 105 is a non-zero number, negative 5 is an x-intercept. Next, when x is equal to 3, 3 squared minus 12 times 3 plus 20, which is equal to 9 minus 36 plus 20, which gives negative 7. Since negative 7 is also a non-zero number, 3 is also an x-intercept. So the function has two x-intercepts, negative 5, 0 and 3, 0. For the y-intercept, f of 0 is equal to 0 squared plus 2 times 0 minus 15 all over 0 squared minus 12 times 0 plus 20, which is equal to negative 15 over 20, which can be reduced to its simplest form, negative 3/4. So the y-intercept is 0, negative 3/4. Example 6. The numerator is x squared minus 5x minus 6. X squared minus 5x minus 6 is equal to 0. The quadratic can be factored into x minus 6 times x plus 1. First, we have x minus 6. X minus 6 is equal to 0. Transpose negative 6, we get x is equal to 6. Next, x plus 1. X plus 1 is equal to 0. Transpose positive 1, we get x is equal to negative 1. Let's check the two values for the x-intercepts. When x is 6, 2 times 6 squared minus 6 minus 3 is equal to 72 minus 9, which gives 63. Since 63 is a non-zero number, 6 is an x-intercept. When x is negative 1, 2 times negative 1 squared minus negative 1 minus 3, which is equal to 2 plus 1 minus 3, which gives 0. Since we get 0, negative 1 is not an x-intercept. So the only x-intercept of the function is 6, 0. For the y-intercept, f of 0 is equal to 0 squared minus 5 times 0 minus 6 all over 2 times 0 squared minus 0 minus 3, which gives us negative 6 over negative 3, which can be simplified to 2. So the y-intercept of the function is 0, 2. Example 7. The numerator is 2x squared plus 7x minus 4. 2x squared plus 7x minus 4 is equal to 0. The factored form of the quadratic is 2x minus 1 times x plus 4. First, 2x minus 1. 2x minus 1 is equal to 0. Transpose negative 1, we have 2x is equal to 1. Divide both sides by 2, we get x is equal to 1 half. Next, x plus 4. X plus 4 is equal to 0. Transpose positive 4, we get x is equal to negative 4. Let's check for the x-intercepts. When x is equal to 1 half, 6 times 1 half squared minus 11 times 1 half plus 4 is equal to 6/4 minus 11 halves plus 4, which is equivalent to 0. Since we get 0, 1 half is not an x-intercept of the rational function. When x is equal to negative 4, 6 times negative 4 squared minus 11 times negative 4 plus 4, which is equal to 96 plus 44 plus 4, which has a total of 144. Since 144 is a non-zero number, negative 4 is an x-intercept of the rational function. So the only x-intercept of the function is negative 4, 0. For the y-intercept, f of 0 is equal to 2 times 0 squared plus 7 times 0 minus 4 all over 6 times 0 squared minus 11 times 0 plus 4, which gives us negative 4 over 4, which is equivalent to negative 1. The y-intercept of the function is 0, negative 1. Example 8. The numerator is 3x squared plus 21x. 3x squared plus 21x is equal to 0. Factoring out the GCF 3x, we have 3x times x minus 7 is equal to 0. First factor, we have x. X is equal to 0. Next, we have x minus 7. X minus 7 is equal to 0. Transpose negative 7, we get x is equal to 7. When x is 0, 2 times 0 squared minus 5 times 0 minus 3 gives us negative 3. Since negative 3 is a non-zero number, 0 is an x-intercept of the function. When x is equal to 7, 2 times 7 squared minus 5 times 7 minus 3, which is equal to 98 minus 35 minus 3, which gives us 60. Since 60 is also a non-zero number, 7 is also an x-intercept of the function. The two x-intercepts of the function are 0, 0 or origin and 7, 0. For the y-intercept, since one of the x-intercepts is 0, 0, it implies that the y-intercept is also 0, 0 or origin. Example 9. The numerator is x squared plus 16x plus 64. X squared plus 16x plus 64 is equal to 0. The factored form of the quadratic is x plus 8 times x plus 8. Since the factors are identical, we only have one possible x-intercept. Just equate x plus 8 to 0, then solve for x. Transpose positive 8, we get x is equal to negative 8. When x is equal to negative 8, negative 8 cubed plus 6 times negative 8 squared minus 16 times negative 8 is equal to negative 512 plus 384 plus 128, which is equivalent to 0. Since we get 0, we can say that negative 8 is not the x-intercept of the function. So the function has no x-intercept. For the y-intercept, f of 0 is equal to 0 squared plus 16 times 0 plus 64 all over 0 cubed plus 6 times 0 squared minus 16 times 0, which is equivalent to 64 over 0, so the answer is undefined. Since we get an undefined result, the function has also no y-intercept. Example 10. Let's equate the numerator to 0. 16x minus 4x squared is equal to 0. Factoring out 4x, we have 4x times the quantity 4 minus x is equal to 0. The first factor is x, so we have x is equal to 0. Next, we have 4 minus x. 4 minus x is equal to 0. Transpose positive 4, we have negative x is equal to negative 4. Dividing both sides by negative 1, we get x is equal to 4. Let's substitute each x value for x in the denominator. When x is equal to 0, 5 times 0 squared plus 20 times 0 will give us 0. Since the result is 0, it implies that 0 is not an x-intercept of the function. When x is equal to 4, 5 times 4 squared plus 20 times 4, which is equal to 80 plus 80, which gives 160. Since 160 is a non-zero number, 4 is an x-intercept of the function. So the only x-intercept is 4, 0. For the y-intercept, f of 0 is equal to 16 times 0 minus 4 times 0 squared all over 5 times 0 squared plus 20 times 0, which gives 0 over 0. This is an indeterminate form, so the function has no y-intercept.